Thanks, Amber. As Amber said, I'm Regina Burris. I serve as the Scientific Program Director for NHLBI's Biodata Catalyst. I also recently moved into the role of NHLBI's Data Science Strategist. NHLBI initiated Biodata Catalyst several years ago to address the needs of the heart, lung, blood, and sleep disorders research community. BDC is a cloud-based ecosystem offering researchers data, analytic tools, applications, and workflows in secure workplaces. It's a community where researchers can find, access, share, store, and analyze heart, lung, blood, and sleep data, as well as an NHLBI data repository where researchers share scientific data from NHLBI-funded research so that they and others can reproduce findings and reuse data to advance science. By increasing access to NHLBI's data and innovative analytic capabilities, Biodata Catalyst accelerates reproducible biomedical research to drive scientific advances that can help prevent, diagnose, and treat heart, lung, blood, and sleep diseases, disorders, and conditions. The ultimate goal of BDC is to facilitate the reuse of heart, lung, blood, and sleep data to drive scientific discovery and ultimately improve the lives of patients. In doing this, BDC actively collaborates with multiple data resources within NHLBI as well as across NIH. Today, I'd like to spend a few minutes providing an overview of some BDC highlights from 2023, asking for your feedback on NHLBI's 75th anniversary, and looking ahead to an exciting 2024. Next. In September of 2023, the Global Alliance for Genomics and Health, otherwise known as GA4GH, announced that NHLBI's Biodata Catalyst was named one of 7 new GA4GH driver projects. The BDC driver project builds on the former TopMed driver project, expanding to incorporate multimodal data and seeking greater integration into the heart, lung, blood, and sleep data ecosystem, as well as international interoperability. BDC also serves as an active contributor to the NIH Cloud Platform Interoperability Driver Project. GA4GH driver projects are globally recognized initiatives that help build and implement standards, tools, and frameworks. They give voice to the broader genomics and health data community and ensure that their products serve real needs, bringing together genomics projects working on data infrastructure, management, analysis, and sharing. GA4GH communities of interest and work streams seek to bridge the divide between technical developers and clinical practitioners. Communities of interest serve a forum for researchers, clinicians, and technical experts in specific domains, such as cancer, rare diseases, and infectious disease, to help define, discuss, and advance use cases that could involve GA4GH products. GA4GH work streams help create new global standards and frameworks for responsible genomic and health data use. An evaluation of a platform's potential contribution to the GA4GH work streams, as well as their ability to expand GA4GH's global geographic footprint, are components of the review process. All GA4GH projects have a mission and goals that depend on real-world genomic interoperability. So it's a very big deal to have BDC included, as well as recognition of our potential to help create and implement new data standards in the future. Next slide. Another highlight this year for BDC was the release of 6 clinical data sets related to sickle cell disease. Sickle cell anemia is one of the most common genetic blood disorders in the United States. BDC hopes to help advance sickle cell disease research by hosting key data sets in its cloud-based ecosystem. We host several data sets that contain genomic data within TopMed, and in the past year, 6 clinical data sets related to sickle cell have been added. BDC offers the sickle cell research community an improved ability to browse the data and facilitates reproducibility. Researchers can collaborate in cloud-based workspaces, create cohorts, and use a variety of tools and workflows to reuse the data, conducting secondary analyses of existing data to reproduce existing findings, as well as to unveil new insights. Researchers are also able to combine BDC-hosted data with data that they bring to the ecosystem themselves. This is the Bring Your Own Data feature of Biodata Catalyst. BDC is increasing researchers' access to key sickle cell data and providing them with enhanced analysis and collaborative capabilities to advance sickle cell disease research for improved treatments to help improve the lives of people living with sickle cell disease. Next slide. These are the current 6 clinical data sets available in Biodata Catalyst, some of which also have associated genomic data from TopMed and biospecimen data available via BioLink. In September, Biodata Catalyst published a blog and hosted community hours focusing on these data sets and featuring some of the sickle cell disease research that has been conducted on BDC. A recording from those community hours is available to you, so please visit our YouTube channel if you'd like to see it. For convenience, the links to all the data sets, the blog posts, and the recording are available on this slide if you are following along. If you're following along with your own copy, they're going to be in the chat as well. We're very efficient. Next slide. Finally, the NHLBI is 75 years old, and as part of our anniversary celebration, we're undergoing a strategic refresh. For 75 years, research programs funded by the National Heart, Lung, and Blood Institute have made important discoveries, developed cures, created new treatments, and improved the lives of people around the world. Working together, scientists, doctors, nurses, patients, and many others interested are advancing science and health. Today, our challenge is to prevent heart, lung, blood, and sleep conditions before they start. In this vision, each person gets the right treatment as soon as they need it. Join us in celebrating the incredible progress that has been made thus far and exploring how we can build on the NHLBI strategic vision for the next 5 years. Next slide. As part of the 75th anniversary, as I mentioned, NHLBI is refreshing its strategic vision to address emerging scientific opportunities. NHLBI's data science program seeks to enable the biomedical research community to harness data science approaches to drive precision medicine for heart, lung, blood, and sleep conditions. This mission involves developing platforms, curating data, developing and implementing policies and practices, as well as supporting external training and outreach and internal staff development. The Biodata Catalyst ecosystem is a foundational part of the larger NHLBI data science ecosphere. Future development of Biodata Catalyst seeks to leverage emerging opportunities in data science to open new frontiers in heart, lung, blood, and sleep research. Please consider responding to the current RFI, which expires in 2 days, particularly if you have data science or biodata catalyst related perspectives on critical research needs or compelling research questions, as well as input on challenges or barriers that need to be addressed to support progress. Next slide. So finally, I'd like to close by thanking those who make Biodata Catalyst possible for their work in 2023 and their continued commitment into 2024. This diagram represents the underlying motivation for BDC. We at NHLBI and on the BDC team are always thinking about the who and the why, the heart, lung, blood, and sleep researchers and the patients they serve and whose lives we hope to ultimately improve. I'd like to take a moment to thank all of the people in the Biodata Catalyst community, like yourselves, who make our community richer. You don't have to be an active research scientist to belong to or contribute to the community. We appreciate your membership in the community and support for the BDC mission, no matter where in the ecosystem you are. If you'd like to become more active in the community, please contact us. The Biodata Catalyst team is here to help. Finally, I'd like to particularly thank the BDC team, the various organizations, including but not limited to NHLBI, as well as our consortium organizations, our passionate researchers and fellows, our data teams, program managers, project leaders, user specialists, and all the administrators without whom BDC would not be possible. Thank you, and I look forward to working with you all in 2024. Happy holidays.
Thank you, Regina. Very, very great presentation, and you're so right. It takes a lot of people to make this ecosystem be what it is, and we thank each and every one of them. We do have time for questions, so I'll open it up. If you'd like to enter your question in the chat, you can use the raise your hand feature, or this is a conversational time if you want to just unmute and ask aloud. Any questions for Regina? Looks like we're getting a round of applause, by the way. Very, very great presentation, Regina.
Yes, thank you.
Okay, hearing no questions, I think we can continue on. Thank you again, Regina. And next up we have Sweta, and Sweta, I'll let you provide your own introduction, a very interesting introduction to yourself and the DMC.
Thank you, Amber, and good afternoon, everyone. Very happy to see the turnout today for the community hours. I'm Sweta Ladwa. I am the NHLBI Biodata Catalyst Data Management Core Scientific Program Director. I also serve as the Chief of the Scientific Solutions Delivery Branch and the Information Technology and Application Center at NHLBI. I'll be talking to everyone about democratizing data, facilitating data sharing, what's been accomplished this past year, and we're looking forward to in 2024. Next slide, please. So many people may not be aware still that Biodata Catalyst established a data management core in the summer of 2021, or 2022, sorry, I apologize. So it's a little bit over a year in its establishment, and it was stood up because it's clear that the data that we have in Biodata Catalyst should be optimized for research reuse. And so the goal is for the BDC Data Management Core to enable data generators to submit their data sets to BDC ecosystem such that high-value data is available for research, it's optimized for reuse, and that process is as streamlined as possible. So they work actively both with investigators in the community as well as with NHLBI program management to identify and prioritize data for onboarding to Biodata Catalyst. They're looking for ways to standardize and streamline the data onboarding process, and some of those the efforts of that area will be made more public, hopefully in 2024. And then they're looking to establish efficient and effective management of data before and during ingest to BDC, so that the data that is available is ready for investigators to use for their various purposes. Next slide. So what does that mean for NHLBI research and Biodata Catalyst? Regina mentioned data science at NHLBI as part of the strategic refresh. And so there are many data generating and data science focused programs that exist across the Institute, including TopMed, HeartShare, BioLink, the Regenerative Medicine Innovation Program, and others. And so the Data Management Core is providing services, including data management expertise, concierge services to ingest data, providing guidance on standards for various data types, as well as metadata, and then technology, whether that's to help facilitate the ingest of data to BioData Catalyst, or to help the end users in using the data that exists on the ecosystem and identifying tools and technology for those purposes. So those are all the kind of various areas that the data management core is supporting to ultimately help those who are supporting research or conducting research using BioData Catalyst. Next slide. So in making the data available in terms of data management support directly in BioData Catalyst, they are looking to increase the quality and availability of the data in the ecosystem. They are looking at both individual study data submission for, because there is the new NIH final policy for data management and sharing, but they're also looking at consortium and batch study data submission for consortia that exist that are pooling data, maybe via data coordinating centers or other means, to be able to support that batch study data submission as well. They are supporting release studies in terms of that's what's available in BioData Catalyst today, and ensuring that folks that are using the data in BDC are able to do so effectively. And then developing methods for prioritizing data for ingest, as I mentioned previously, including feedback from programs across NHLBI and program officers to understand, what investments NHLBI has made in data generating programs and prioritizing those that are ready for sharing in BioData Catalyst. Next slide. A lot of data has been ingested over the past year. You'll notice that a lot of that is focused on TopMed. TopMed is one of the large data generating programs at NHLBI. We have in BioData Catalyst today close to or slightly over 4 petabytes of data. And a lot of that, you can imagine, is due to the omics data coming from the TopMed program. And for those who are not familiar with TopMed, that's the Transomics for Precision Medicine program. It's a multi-omic program that's primarily generating whole genome sequence data and is shifting to include other omics data types such as metabolomics and proteomics. So there's a lot of TopMed, all the TopMed data up to Freeze 9 is available on BDC. Some of the phenotypic data from Freeze 9 is available, but we are actively working to ingest the phenotypic data from Freeze 9 as well. And then we'll be moving to Freeze 10 in early 2024. We've also been working to incorporate a lot of the COVID-19 data sets that have been generated from various efforts, including Connects, which is the collaborative COVID network of networks effort that is looking to bring together all the various COVID studies that NHLBI is invested in a consistent manner with standardized metadata to make that data available in BioData Catalyst. So Connect studies are coming in. C4R, which is part of Connects, is another network of COVID studies that have to do with the NHLBI longitudinal cohort studies, such as Framingham and Cardia Jackson Heart and others. And so there's a COVID-19 related arm of those studies that fall under the C4R bucket. But we also have our traditional clinical studies that are coming in as well. And so there's people can notice that there's a much more greater variety of data that came in over the last year. And that's going to continue to expand as BioData Catalyst expands its multimodal data availability in BioData Catalyst in terms of the hosted data that exists for reuse. And that's going to continue to grow. Next slide, please. So in terms of our present state with regards to data, there's been and this is not just BDC specific, but kind of looking a little bit more broadly in terms of what's going on in research, where there's previously been centralized access to data, some tools for conducting primary, secondary analysis, developed for program specific needs. There's maximal guidelines for maximal reuse of data standards. It's all kind of disparate right now. And, we work with investigators, kind of individually to propose standards, harmonization strategies, and metadata requirements for various data types. And what we're really looking to do is move forward in the future to facilitate the efficient and secure data sharing with collaborators, in a federated manner. And so that includes some of the interoperability projects that Regina mentioned previously. But we want to move to, having these custom tools that are available in disparate programs or resources and have them hosted in Biodata Catalyst so that they're available to the community for reuse alongside the data. We want to be able to continue to grow the new data types that are that exist in Biodata Catalyst that pertain to heart, lung, blood, and sleep research, and ensure that they're available to the community as well. But really, ultimately, is to drive towards advancing scientific innovation. So everything we're doing today is to enable the success of our researchers, and so the success of the researchers really ultimately. So the success of Biodata Catalyst lies in the success of our researchers. And so everything we're doing in terms of building the ecosystem and, expanding the data types, making the tools available is to really drive towards scientific outcomes and improving the health of those affected with heart, lung, blood, and sleep related diseases and disorders. So we're happy to take feedback and continue to grow the data and the tools that are available in Biodata Catalyst to drive towards that outcome. Next slide. So to that end, we're really looking to move towards NHLBI program integration. As part of that data science ecosphere that Regina mentioned, we recognize that BDC is a pillar of that, but our programs that are generating the data are definitely a part of that ecosphere, and we want to more closely integrate with those. And so our primary focus is on 3 areas to best support that NHLBI program integration to Biodata Catalyst, and that includes metadata to find, access, and effectively reuse or reproduce the data and the results. We want to be able to support the effective reuse of tools that help to also reproduce the data and results, but help the end users in using the data types that are available in Biodata Catalyst. And then linkage, where there are individuals that have multimodal data in programs that are generating those multimodal data, like for example, individuals in the longitudinal cohort studies that may have genomics data as well as clinical data, but also imaging or sleep-related actigraphy data and other molecular data. We want to be able to ensure that there's a privacy-preserving mechanism to provide that linkage information while preserving the privacy of the individuals in line with the consent that they signed at the time of the original study. So those are the 3 primary focus areas to bring in the existing programs under kind of the BDC umbrella, but really to work collaboratively with the programs and have a home for them longer term. So not only to make the data available to the consortium, the communities that generated that data, but to the broad biomedical research community. And we want to be able to support fair data sharing, including support for the NIH final policy for data management and sharing. And so since Biodata Catalyst is a multimodal, supports a multimodal data repository, and we are a recognized repository at the NIH level, we are here to help our investigators comply with the final policy for data management and sharing. And the data management core can definitely help provide more information to that end. So I believe that's my last slide, and I'm happy to take questions if there are any.
Yeah, thank you, Sweta. That is your last slide. And again, we'll open the floor for questions. So if you have any questions for Sweta about the DMC or about data in BDC in general, Sweta is our expert. So feel free to unmute, or again, you can use the chat feature, whatever you prefer.
I have a question in the chat for Sweta. Does the BDC provide a template for NIH data management and sharing?
So Biodata Catalyst does not have a template, but if there are folks that are interested, you can actually work with your program officers to establish obtain templates. There are resources available on the NHLBI website that has additional guidance for the final policy for data management and sharing, including templates for the data management plans. So there are definitely resources available, and we're happy to provide pointers if folks are interested, but BDC specifically doesn't have templates specific to BI Data Catalyst yet.
And we did have a question come through earlier, and I'll put it in the chat, Sweta, but I'll read it aloud. Given the success of UK Biobank's multi-omic data analysis project and the growing interest in combining omic data sets for novel health-relevant insights, how are you incorporating large cohort multi-omic data sets on BDC?
Thanks, Amber. Yes, so I talked a lot about how we're working to incorporate large multimodal data sets from cohorts in BDC. We already have significant genomic data available from PopMed as well as the clinical data. We are working actively with HeartShare to bring in a lot of the imaging studies from those longitudinal cohort studies. I think one of the key areas of contrast with UK Biobank is that the longitudinal cohort studies that NHLBI has invested in have been in effect for generations and decades, and so we are looking at decades old programs where data was collected, and we're kind of retrospectively having to align that data for reuse if in BI Data Catalyst, whereas I think UK Biobank, if I understand, they had started from the get-go with a very open kind of recruitment effort and started de novo. So it's very different use cases in terms of the way that the programs kind of came together. And so, they had the foresight to be able to plan for that multimodal data from the beginning. But NHLBI and PopMed does have one of the most diverse sets of whole genome sequence, and to correspond and correlate that data with all the other multimodal data that exists, including the sleep data and the imaging data, we're really hoping to provide that to the community to advance outcomes. So there's a lot of work going on in that space to be able to provide the multimodal data to the community, some of which already exists in BI Data Catalyst, and a lot more to come in 2024.
Thank you. And it looks like we have another question that came through the chat. What is your strategy and prioritization for supporting ingestion of non-standard or supplementary data that doesn't fit the current BDC data model?
So there's no actual BDC data model. And so, we can actually technically ingest any data type as a blob because we are cloud-based. What really makes data useful in BI Data Catalyst is the metadata associated with the data and the tooling to reuse that data. And so we can ingest, non-standard or supplementary data. It just depends on, how best that data might be reused in the ecosystem. What is the intended use case for that data that we, how can we best support that data availability in BI Data Catalyst? And so right now, if you look to the guidance that's available on the NHLBI website in terms of the final policy for data management and sharing, BI Data Catalyst may not be the best repository for all data types. So it's up to the program officers and the investigators to collaboratively establish, what repository might be a best fit for the data types. NHLBI does strongly recommend BDC for most human subject-related data deposition. And so, if there are thoughts around data types that are maybe considered not to be supported and what that would take, we're happy to take the feedback and build that in, for consideration. I hope that answers your question, Joshua.
I guess to expand on that just a moment, there's always a question of what's data and what's metadata. From your response, I guess I would rephrase my question to say metadata. So if you are collecting data on people or subjects, but I might have additional metadata on that subject that I have collected that doesn't fit the fields that are currently present in BDC. What's the strategy and prioritization of allowing submission of that extra metadata so it can be reused by other researchers?
If that data is NHLBI funded data, then we can work with you to ingest that metadata as well. If that data comes from other institutes, then we do have to work collaboratively with in terms of funding I'm talking about here. We would have to work collaboratively with the other institutes to ensure that that data can be ingested and hosted in BioData Catalyst. But there's no data model. It's not a database. It's very flexible in how we ingest data. And so we definitely would want to create, if there are metadata that exists on individuals we already have in the ecosystem, we definitely want to provide that context to our end users.
Thank you.
And it looks like we do have one more in the chat. Is data upload limited to only NHLBI funded projects, or can anyone upload data to BDC?
That's a great question, Alex. Our primary data upload focus is those that are NHLBI funded projects. So when there are non-NHLBI funded projects, if it's funded by another institute at the NIH, we do want to work collaboratively with those other institutes to ensure that BDC is the right home for that data long-term, and that there are appropriate, permissions and governance in place for those non-NHLBI funded projects related data. So, and those are handled on a case-by-case basis, but we are primarily, we primarily support the hosting of NHLBI funded project related data.
Thank you, Sweta, and thank you for answering my earlier question. Just based on the previous one, I wanted to ask again if it was limited only to NHLBI funded projects. So thank you for that as well.
Absolutely.
Yep. Thank you, Sweta, for your very informative. I know the DMC is a very interesting topic, and data, of course, is a very interesting topic for all of our attendees. And thank you for your questions. I do want to make sure we have enough time for our guest researcher, Brandon, to present with us. But we will have time at the end again for questions. So if you stay on the line, we'll have a discussion portion again after Brandon presents. But Brandon, I'll let you provide your own introduction, but I do want to say congratulations. Brandon has recently defended and gotten through his dissertation and is now a PhD. So congratulations to Brandon. He's been an advocate user for BDC for quite some time. And I'm looking forward to hearing what his latest update is. So without further ado, Brandon.
Got it. Thank you so much, Amber. Yeah, my name is Brandon Lee. I was a PhD candidate at Duke University, and my work has really been focusing on a lot of the top metadata sets that were previously mentioned. So I'll give a very brief introduction to what I do, and give a little bit of a retrospective on my experience with the ecosystem from a user perspective. So yeah, next slide, please. I work on the genetic and omic modifiers of sickle cell disease. You've heard a little bit about that from Gina. I won't go into the nitty-gritty right now, but my work on sickle cell disease comprised multiple projects, mainly association studies, working with genetic and other omic data sets like methylation data sets. And a lot of that work was performed on the ecosystem here, of which I have to credit a lot of my success and the work that's eventually published into my dissertation stuff. So that's why I'm here speaking with you today. I used to be a fellow with BioData Catalyst, part of the second cohort. And as a fellow, I not only performed that research on the ecosystem, but also assist in development of it, providing my own feedback from, again, the user perspective, seeing what areas would be useful to researchers and what areas could could grow and be improved upon. So I'm happy to share with that with not just you all today, but also with the folks from BDC present on the call. And I'll be talking a little bit about that in the next slides to come. So next slide, please. As to what I exactly did on BDC, I performed multiple analyses of the ecosystem, which essentially composed of association sites of renal function in sickle cell disease. I achieved this through the data from TopMed. There are multiple sickle cell cohorts that were not just mentioned previously, but also some that BDC had adjusted earlier. And it was through these studies that I was able to expand the scope of my research, include a lot more samples, improve statistical power, and just really be able to assess sickle cell disease through a broader lens, looking at multiple ancestries, multiple genetic backgrounds, really allowing my project to encompass more of what I had wanted to assess during my analyses of sickle cell. So I mainly performed this work on the 7 Bridges platform as part of the BDC ecosystem. That's where I performed the majority of my analyses and spent the most of my time. There, I developed workflows and imported tools myself that I would have to use in these association studies. And beyond that, I participated in the community, really participating in other community hours like this one, attending quarterly meetings and various working groups. And it's really through these experiences that I got to experience what development of the ecosystem has been like over the past few years, as well as contribute some of my own thoughts, of which I'm more than happy to share, because ultimately the ecosystem was built for folks like me and other researchers, whether it's early career researchers or all the way up to late stage researchers. I really feel this is the platform to help push all of these projects forward and make it easier for us to find the results we want to find. So next slide, please. This is a slide I gave during my dissertation seminar. I just wanted to show this to you quickly, not because I think you need a refresh on this, but just to show that this is what I'm talking about in front of other people. This is the data I'm using. This is the toolkits and ecosystems I'm working with. And this is really just to give a sense of, I really want others to know about this because it has genuinely helped me perform my research, and I would not be where I am today without the use of TopMed and Biodata Catalyst. Next slide, please. To give you a little bit more detail as to the work I performed, I really used not only the tools that were imported to 7 Bridges. So these include what you might consider the standard or classical genomics analysis toolkits like DCF tools or Planck or whatnot. I was also able, through this platform, to go in and edit those tools, just put in additional functionality that I would use in my own analyses, as well as import separate apps that, while they may not be already included, that I was able to compose containers for, import them to the ecosystem, and eventually have them running alongside and part of workflows that also integrate these other built-in tools. So it is a pretty flexible system for me to conduct different types of analyses that may or may not already be included on the ecosystem. I think that's a benefit of it. There are tools on the ecosystem that I've been able to test and have rapidly integrated to my own workflows, like the Annotation Explorer. So it's I feel it's a hotbed of activity where you can go in, put in your own tools, and see really what the ecosystem's up to in terms of whether there are new tools that a lot of researchers like me would have wanted to see on a platform and are able to see actualized. So it is, I think, a very rapid area of development. That being said, I'm able to also contribute this effort through all the various community-based approaches, not just my physical work on the ecosystem, but also through just talking with support or just attending all these various community events and meetings where I can learn from them and they can hear from me about our various experiences. So I feel that's a critical part of what makes Validated Catalyst unique and special in its own right. Next slide, please. This is also a slide listing out the methodology from GWAS I did. I'm not going to go through this in any level of detail, but only to show that there are multiple steps of this to the analyses we do, right? Anyone who's done GWAS will know that these are all the critical parts of it, just doing basic quality control of filtering, controlling for population substructure, and controlling for covariates, and actually doing the analysis. What I wanted to highlight here is that all this, I was able to basically translate from bash scripts I've run on local computing clusters all the way to the workflows I've set up on Data Catalyst. Next slide, please. So this is one of the examples. This is one of my actual workflows that I use, and this is the relatively simple linear workflow that I've set up, where you have various nodes that do individual steps of that filtering process, each individual node representing one, maybe two functions, to clearly delineate what I want to have executed on my base genotype call files. Next slide, please. And this is another example. While it may not be as well annotated, I'll go back and fix that. This is just to show that you can scale this up to lots of different tools and apps, lots of different inputs and combinations of inputs and outputs. And ultimately, the fact that you can apply these to the different cohorts or data sets that are either already available on the ecosystem or data sets that you may choose to import yourself. And that was a key part of it as well, the flexibility for me to bring my own data, because I did do a little bit of that. Imported my own phenotypes, imported some custom genotype call files that I had done some independent filtering on before usage on BDC. So next slide, please. And ultimately, I have a few takeaways from this. Highlights of it, a robust support system. It's not just the community, which I've talked a little bit about, but also just the actual structural analysis support. Of course, my experience only extends mainly towards Seven Bridges, but I imagine this applies to all the other platforms on the ecosystem as well. The fact that you can get direct help with your analyses, I've relied a lot on that in order to troubleshoot and figure out what might have gone right or gone wrong with my analyses. So that definitely helps a lot. More broadly, I think this kind of research provides more accessibility to high performance computing to a broader range of researchers with various skill sets or interests. For me, I did have more of a computational background going in, so it's relatively easy for me to come in and pick up stuff and learn as the platform developed. But there's lots of opportunity for other researchers who may not have that experience with high performance computing to really go in and say, I don't know that much about it, but I want to learn because I have these cool ideas as to how I can use data sets X, Y, and Z and apply methods A, B, and C to them. I feel that platform's really built for that and really geared towards that core area researchers who don't know where to start, but need some sort of a helping hand to guide themselves in. And I feel this is there are supports in place for us to do that here. Ultimately, structurally, it allows scalability, parallelization, reproducibility to all of our analyses, which no one can complain about. In terms of continued growth, I always appreciate the continued inclusion of additional tools. I've included stuff that I've imported myself. I hope to see them, eventually integrated into the core set of tools available on Seven Bridges and broadly BDC. But I think that's what will help continue the ecosystem to grow and to evolve alongside the needs of researchers. That it's not just the tools that are currently available, but also the ones that are continually being developed and continually being released that will help new researchers be introduced to the ecosystem. I have this new tool that I know how to use locally, but I'm not sure how to translate it to a cloud computing context. Could I get some help with that? I feel that that's part of the continued growth of the platform and where a real strength of it will come from. Data access. During my time as a BDC fellow, I've been fortunate to be associated with a lab that has TopMed access coming in. We use a lot of TopMed data sets regularly, so I'm very familiar with the process for getting data access and already having that access. But for a lot of other users, it's not that intuitive. And that's not the fault of any one person in particular, but through the growth and ingestion of all these new data sets, the evolution of how to gain access to them in the first place would definitely help researchers be onboarded and help facilitate the speed at which they can actually perform the analyses with these new data sets. And ultimately, just continuing to have additional users onboarded onto the platform, one, helps their own research in terms of providing access to a computing cluster, but also provides more support to other members of the community. I'm standing here now as a testament to that, where I can say I started from not really knowing how to do high performance computing all the way to where I am now, about to leave Duke University and handing off all the knowledge, data, and workflows and tools I've developed to other members in my lab so they can continue the analysis that I've done. I feel that's a key strength of having all of these, having new users being able to be onboarded, as well as having all these mechanisms for reproducibility and sharing data sets and tools with others. So with that, that's all I have to share. So that's it for me. Thank you very much. And I'll take any questions you have.
Thank you, Brandon, and congratulations again. Per usual, we will open it up for questions. So again, feel free to unmute yourselves, or if you want to post your question in chat, whatever you prefer. But thank you, Brandon. We've been working closely with you for some time, and it's really great to see your success, and we're so excited to see what you do in the future. And again, any questions? I think all of our speakers are still on the line. So whether you have a question for Brandon, Regina, or Sweta, feel free to ask it now. Or if you have a question about BDC in general, we're happy to help. We also have representatives on the line from the various components of the ecosystem. So any question you have, we still have about 6 minutes left. Maybe some people are posting in the chat or getting ready to ask a question. But before we all leave, I do want to say a big thank you. I want to echo Regina's sentiment earlier. Thank you to the BDC Consortium. Thank you to our BDC ecosystem reps. And of course, thank you, to all of the wonderful participants that we have at these community hour sessions. I think we've had a really fabulous year this year. 2023 has been great. I think 2024 is going to be even better. And none of this would be possible without you. So thank you to everybody who has joined us. And thank you again to the consortium and all of our representatives who work really hard behind the scenes to make sure that these monthly hours happen. Just thank you so much. I know I appreciate it. And I think we all appreciate each other in this community, which is a really wonderful thing. So again, we still have 5 minutes of time and our speakers are still here. So I will open the floor. We will have a short survey that comes up. It's anonymous. So please, your feedback matters so we can improve future sessions. Submit unanswered questions to our help desk, join the community, register for January. That's my whole spiel, but I'm going to leave the floor open for any questions, any comments that you might have.
I'll just come in and echo what Regina just put in the chat, which is a big thank you to Amber for leading these community hours and driving them to success. And thank you all so much for making very big shoes for me to fill for next year. Just a very short plug for our January Art of the Start panel. We're looking at early career researchers who use BDC in that panel. And we're looking forward to early career researchers, aspiring researchers, but also experienced researchers coming in and joining us and maybe putting some of their own tips and suggestions for early career researchers in the chat. So we're hoping to welcome everyone in January.
Oh, thanks, Dave, for putting that in the chat. I'm not sure it's clickable, but people can copy and paste. And a recording from today will be sent out as long as you registered for the event. You will get a copy of today's session. The slides are on the forum. If you don't want to go looking for them now, that'll also be in an email. So watch your inboxes for the recording and slides if you want to refer back to anything. Big thank you once again to all of our guest speakers. Thank you to everybody who joined us. And yes, happy holidays to everybody. We will see you in 2024. We do have 3 minutes. I always stay to the end just because you never know when a question might come up. So still feel free to unmute yourself if you have a question or put it in the chat and we'll make sure to get to you.
Amber, there's a question in the chat I'm happy to take.
Yeah, I was just going to unmute. If you would want to do that, Sweta, that'd be great.
Sure. The question is how to gain access to the data on sickle cell disease. Right now, you can actually submit a data access request to the data on dbGaP. You can search for the specific data set you're looking for, and there's guidance on how to do that that's available on both the Biodata Catalyst documentation website that maybe we can put a link in the chat too quickly, as well as on the dbGaP website. So you would request access to those via dbGaP, and I'm going to try to quickly put the link in the chat.
Yeah, if you have it, Sweta, you can put it in there, but we also do have the email, so we can also send follow-up instructions via email, and I'll make a note of that if you can't find it in time. Oh,
Got it.
thank you. Thanks.
Sure.
It's always a race against time with some of those links. Okay, well, we're coming up on just under a minute, so I think we can close out unless there's any last questions. I'll give it maybe 5 to 7 more seconds.
I will say that when you do submit that data access request, as soon as it's approved, hopefully within a few hours, if not the next day, you should have access to that data in Biodata Catalyst.
All right, and we're right at 2 o'clock. Thank you, everybody, for another wonderful session, and we'll see you in 2024. Hope everybody has a really great afternoon.